Welcome back, chemistry fans. Today we are going to do our third set of homework, and this one is dealing with gas laws specifically. We're going to get into the combined, and we're going to get into Avogadro and Gay-Lussac. So let's jump into it right now. 3 problems in your homework. Let's see if we can find them here. Boom. Okay, so in this first problem, it says that you are given the container holds 45 grams, 2.8 atmospheres, but an additional 50 grams. So right away, what I notice is that there are two there are two conditions to start, but then there's a repeat of one of them. So that tells me right away I am not dealing with PV equals nRT. It tells me what I'm going to have to start to deal with is the other formula, which is the combined gas law. PV over T equals PV over T. NT. And what you will notice in this one is that you are given grams and atmospheres. Those are pressures, and those are moles. So our equation ends up being the P over N equals P over N. But the 45 grams is going to need to be converted into moles. So we've got to do 45 over 32. And that's going to be 1.4 moles. So that's our starting amount. So we're going to put into this equation P over N. So I'm going to put the 2.8 over 1.4. We don't know the new pressure, but we do know that an additional 50 grams. So if I were to add 50 grams to this, well, then I would have 95 over 32. And that's 2.97. And this is, I'll do 4-1. Okay, so 2.8 times 2.97 divided by 1.41, and you get E2 is equal to 5.9. 5.9. Ooh, you can't read that. 5.9 what? Atmospheres. So it increased in atmospheres because you increased the amount. That makes sense. All right, number 2. Again, is it PV equals nRT? Well, let's find out. We've got a volume, we've got a pressure, and a temperature. That's starting to look good, but it increases by 1 atmosphere. So right away, I know I do not have PV equals nRT because I have a few items that have changed. And so that means you have to deal with the combined gas law. And what you will notice is I have a new pressure, a new temperature, and it's asking for a new volume. So that means everything stays in this equation except for the moles. So we're just going to plug it all in and convert them into the correct units. So my pressure, it says, is 780 millimeters of mercury. That can stay as a pressure. That's fine. My volume needs to be 0.5 liters, and my temperature needs to be converted into Kelvin. So I will add 273 to 90. And what you get is 363. Now, what happens is the pressure went up by 760. Whoa. I'm sorry, by 1 atmosphere. Oh, I just let it out of the bag. So the 760 is the conversion for millimeters mercury. So I've got to add 760 onto 780. They've got to agree with one another. So that's 1540 is my new pressure. My new volume is what we're looking for. My new temperature, it increased by 50 degrees. It's not 50 degrees, it increased by 50. So it would be 50 plus 90 plus 273. So to my temperature, 90 plus 50 plus 273, I get a new temperature of 413. Now it's just cross multiplication for all of this. All right, so 780 times 0.5 times 413 divided by 363 divided by 1540, and you get your new volume is 0.288 liters, which is the same thing as 288 milliliters. Okay, now number 3. So let's see if we can get number 3. And what happens to the temperature if the gas it begins it is 80 degrees? So it begins at 80 and temperatures are always on bottom, and the pressure changes from 34 down to 16. So we've got 2 sets of temperatures, we got 2 sets of pressure, so it is not PV equals nRT, and it is temperature and pressure, so that is going to be Gay-Lussac, so we can get rid of volume, and it's P over T. So we're looking for the new temperature, but this temperature, it's already in Kelvin, so we don't have to make a conversion. So I'm just going to cross multiply 80 times 16, and I'll divide by 34, and you get my new temperature is 37.6 K. All right, this is everything that I was hoping that you would learn and demonstrate that you have knowledge of for the new sets of equations. Thank you so much. I will talk with you again soon. Bye-bye.